Okay, so let's learn how to use Spearman's rank correlation coefficient. The first thing we're going to do is rank the numbers here in test number 1, although it really could be for any set of numbers. Anyway, we're going to rank them from highest to lowest. Now the highest number in this case is 99, and that's what we're going to assign the rank of 1. So your rank of 1 is for whatever the highest is. Then we're going to go in order. So 88 is the second highest, so that's number 2. 80 is number 3. 74 is number 4. 62 is number 5. 44 is number 6. And if you can believe it, 3 is number 7. Now we're going to do the exact same thing here well, it's not the exact same because it's different numbers, but we're going to do the same process for test number 2, or our different data set. So the highest number is 90, and then wait, hang on, stop the record. We have two numbers that are the same, 89 and 89. So here's what you're going to do for that. These ranks are going to be, well, these numbers are going to form the ranks of 2 and 3. But if we did that, that wouldn't be the correct rank, because 89 and 89 are both the same number. So how can one be higher than the other, I can hear you asking. Well, they can't. So what we need to do is both ranks, we split the difference. So both ranks become 2.5 and 2.5. And then our next highest is 77. That becomes, nah, just joking, not 3, it becomes 4. Because 2.5 and 2.5 here are our two ranks that are taking up the positions of the second and the third. Hope you're still with me. Okay, so number 5 is 61. Number 6 is 30. And then this poor guy can't catch a break, he's at number 7. Okay, so once you've ranked both of your two sets of data, you then need to figure out the D. D just stands for difference in this case. So you do this one minus this one equals this one. So 7 minus 7 is 0. 6 minus 6 is 0. 5 minus 1 is 4. 3 minus 4. 3 minus 4 is minus 1. 2 minus 2.5 is minus 0.5. 4 minus 5 is minus 1. And 1 minus 2.5 is minus 1.5. Okay, so the D squared is the difference, which is this column squared. So all the zeros are really easy because nothing squared is nothing. So 0, 0, 4 squared is 16, minus 1 squared is 1, minus 0.5 squared is 0.25, minus 1 squared is 1, and minus 1.5 squared is 2.25. So now we add up everything in this column here to get the sum of D squared, which in this case is 20.5. Just ignore how that's all tiny like that. Here, maybe I'll make it bigger. Boom. Okay, so 20.5, wait, I think I said minus 20.5 before. Anyway, it's 20.5, so that's the sum of D squared. Okay, so now we're going to figure out the equation. So I've just copied and pasted it down here. So the equation is R, so rank equals 1 minus 6 times the sum of D squared, so D squared is 20.5, over n cubed minus n. Whoops, forgot to tell you what n was. We'll just scroll back up. N just stands for number, it's the number of ranks. So in this case we have 7 ranks, so that's 7 sods. Okay, so let's work out our equation. So we've got R equals 1 minus 6 times, oh that's not 100, sorry, that was from another thing. Being really professional with this video. Okay, so R equals 1 minus 6 times D squared, which is 20.5, 20.5. And that's going to be over number cubed, so number is 7 minus 7. Okay, so the next part of our equation, so in that case then, so 6 times 20.5, 20.5 is 123. So 123. And n cubed minus n, so 7 cubed is 343 minus 7. 343 minus 7 is 336. 336. Oh, you're joking me. Is that... so 336 goes in here. When I can get it to cooperate. Oh, there. Oh. Boom. Okay, 336. So, next part of our equation is to figure out what 123 divided by 336 is. So, 123 divided by 336, you're looking at a big number. We can get rid of this guy now. We don't need him anymore. So that equals 0.3660. We won't round up any more than that. And now this is the point where some people go, yep, I'm done, I can move on. But you can't, because there's this part here. So we're still going to do the 1 minus. So R equals 1 minus, and then that, well, we don't need to do that. So R equals, and then 1 minus 0.3660 equals equals 0.634. Now, because this number is greater than 0.5 and there's no minus in front of it, that tells me that it is a strong positive correlation. So what that means is, if you do well on your first test, you're likely to do well on your second test. And similarly, if you don't do so well on your first test, like this poor guy who's only managing to get 3 out of 100, they're seriously not studying, then the same is probably likely to happen for the second time around. There are some outliers though. So this person did 62 and they got 90 on their second test because they listened to their teacher and they studied hard. Hope this was helpful.